our next presenter, Topaj Alexander Grigorievich, and he will tell us more about the problem of optimal ice routing. Please, Alexander.
I continue the theme of ship optimal routing in ice. Last POAC, which took place in Delft, I presented the efforts of our team intended to development of different digital services of Arctic navigation, the ship transit model, and also the algorithms and methods for finding the optimal path of the ship in the ice. And the expectable and reasonable question I had there was, do you have some results about the verification of your approach and sensitivity analysis or analysis of uncertainty factors? And I have answered, yes, we did such activity, and I promised to present some such results to the next POAC. Now I follow my promise. The theme of my report is comparative analysis of uncertainty factors in the problem of optimal ice routing. I try to speak English, so you must suffer my terrible pronunciation. So, first of all, we can consider the causal chain of uncertainties in ice ship routing. It means the different input data and different computational components we need to use in order to find the optimal path. The ground of ice data for the moment is the remote sensing data or satellite images. It's now the main source of data about the actual ice. On the base of this remote sensing data, or on the base of these images, the specialist can recognize it and to elaborate the diagnostic ice charts, the electronic maps, these geo information, which present the actual state of the ice. On the base of the diagnostic ice charts of the instant situation of ice conditions and Meteoscience models and forecasts, the specialists can construct the forecast ice charts, because we need to know not only the current state of the ice in order to elaborate the optimal path, but the future dynamics of ice conditions during the long-term voyage of the ship. On the base of the diagnostic and ice forecast charts, we can estimate for every temporal and spatial point of the media the achievable speed of the investigated ship, achievable speed, and the fuel discharge. All the propulsive characteristics we use to optimize the route of the ship. Ship transit model use the data about the actual and the future ice, and also the ship information model, the description of the propulsive abilities and opportunities of the current ship. And after that, we can use the different methods of numerical optimization and to find the optimal or quasi-optimal route, quasi-optimal path, this ship in the changed media. And all these components, all these data sources intend to the difference between the automatically obtained route or manual routes or shipmaster decision in reality, because in shipmaster decision in reality influenced the different subjective factors, for example, rush or supplementary task of ship voyages and so on. And we need to investigate, to analyze all such uncertainty factors. In order to do it, we have the many data sources to compare the different approaches. For example, we use many data sources about the current ice and forecasted ice state obtained from different providers. We used the diagnostic ice charts from Arctic and Antarctic Research Institute, and so also the forecast ice charts from the same provider. We use the ice charts, both diagnostic and forecasted, from another provider, whether the company VNI from Japan, and also the diagnostic ice charts from European community OCSAF, with Finnish and Norwegian Meteorological Institute. We use the original satellite images to analyze the actual voyages of the ships, and also we use the dispatcher on-board reports on Arctic ship voyages, and also the detailed expedition logs, which were made by the specialists of Arctic and Antarctic Research Institute in the special expedition voyages. And our big thanks to Sergei Viktorovich Frolov from Arctic and Antarctic Research Institute, who provided us this data. And in order to compare the automatically obtained quasi-optimal routes and the real routes or real voyages of the ships, Arctic ships, we use the ice tracks and recommended routes from the ice expert from Arctic and Antarctic Research Institutes. The next slide presents our estimation of the comparative quality of ice data from different providers. First of all, the comprehensive ship transit model needs to have many characteristics of ice as an input data. We need to use the concentration, it means the percent of the ice covered by the investigated area, the age of thickness of the ice form, it means the characteristic horizontal size of the ice floes, compression, but not only the strength of the compression, but also the direction, because the influence of compression direction has a big impact and big influence into ship propulsion abilities. And I will demonstrate it later. Hammocks and leads, local leads, breaks in ice fields, and for example, the amount of snow lying on the ice. You can see how which information has the different providers in provided data sets. So the orange or red color is the absent data. The yellow one is the data having the problems. For example, these data have a definite cost and one need to pay, or it's not free, and so on. And also we investigated the genesis. What is the genesis of the corresponding data? It's actual monitoring or the model calculations, the resolution, both temporal and spatial ones, and the format. You can see that, for example, the data from RRE has a good detailness, good genesis, a good resolution, but unfortunately, we receive the free data in so-called secret conventional codes, but it's clear that for the model, the more valuable is the data in physical numbers, in physical values. And first, what we can do is the comparison the data about ice obtained from different providers. For example, for this slide, we can see the comparison of data obtained from Arctic and Antarctic Research Institute in Vienna about the ice concentration for 2 different days. We can compare it visually. But in order to have the strong and trustable estimation of data correspondence between each other, we use the mathematical approach. If we compare 2 ice charts, we use the regular grid of benchmark points, and we receive the investigated ice characteristics from first and from second ice chart for all the points, and we receive the 2 samples, 2 sets of values, and after that we can formally compare it by means of standard statistical routines. The next slide presents the results of the comparison of different ice charts. For example, current total concentration from Arctic Research Institute and Vienna, and the correspondence between the data is for the same time period and for the same area, and the comparison between forecasting and diagnostic characteristics from the same provider. How valuable and how good the forecast obtained from this provider is. And the main conclusion what we can make analyzing this table, that the main problem is not the forecast. The main problem is the critical difference between the diagnostic, between the actual data obtained from different providers, even if they have the same source, the same satellite or radar images to recognize the current picture of ice state in the region. The next step of our investigation is the sensitivity analysis of ship transit model to the lack of this or that data about ice. For example, Arctic and Antarctic Research Institute provide the data about ice in the area for 3 different development stages. So in the concrete point, we have 3 values: the biggest, the oldest ice, the young ice, and so on. And we have different values about the thickness, about the concentration, and about the form. Other providers have only 1 conventional value. And the left chart presents the investigation of the problem. What we have if we don't take into account the 3 stages and change it to the 1 conventional value. For example, for weighted average value according to the partial concentration, it's a blue points, or more sophisticated method taking into account the ability of navigator to select the more profitable and more easy way in the media with different characteristics in each concrete point. We can see that the lack of detailed description of the ice for different development stage decrease the accuracy of the model. The right chart presents the results of importance the ice form. Many providers do not obtain the data about the ice form and only concentration and thickness. And we do not know whether the ice is brush ice or they has the solid structure and have no cracks, leads, and so on. And in this case, in the right chart, we can see the comparison of ship speed calculated from actual ice form data and ship speed calculated with a faked and fictitious ice form. And you can see then if we have the small size of the flows of brush ice, the difference between actual and fictitious data may be significant. The next slide presents the results of the importance for the results of the ship transit model, the achievable speed mainly, the ice compression. No one providers provide the data about ice compression, only the strength. But in this chart, we can see how the direction of the ice compression, frontal or tangential one, have the influence on the achievable speed of the ship. You can see that for the powerful nuclear icebreaker, the influence is not so significant. But for example, for Yamal Max LNG tanker, like Christophe de Margerie, this influence is very significant. Next investigation is investigation of ship transit model verification selected results. We use the onboard reports of the records of Christophe de Margerie and compare the actually observed velocity, speed, ship speed and velocity with our forecast, our estimation. And we have many detailed results, but in this slide you can see only selective ones. The next table presents these results in table form. And we can see that the correlation between the factual and estimated ship speed in the point is more or less normal. And our ship transit model can more or less predict the actual propulsion properties of the ship in the concrete ice state. The same results in graph presentation. And the big problem we analyzed during this investigation is that the discrete character of the observation in onboard reports does not permit us to estimate the ship speed in the point accurately, but only in ice zone, because very shortly the characteristic speed in the more or less homogeneous uniform ice zone depend on the size of this ice zone. But the moments of receiving the operative records do not correspond to the boundaries of the ice zone. And in the result, we have overestimation or underestimation of the calculated speed. And the next slide is the verification of the ship ice routing itself. So we have compared the actual tracks of Arctic ships, several tracks of Arctic ships. These our recommendation obtained from our digital services. And we can see that from time to time, we have more or less correspondence between the model obtained optimal route and the decision of shipmaster. And another case, in another cases, we have the real big difference between our recommendation, our thinking about the optimal path of the ship and the shipmaster decision. And for example, in the right picture, we can see that the influence of subjective factors can also be taken into account. We have this is a satellite images and satellite image, and we can see the big lead on big crack almost on the course of the ice ship, but from this or that reasons, shipmaster do not use this crack and use it only in the short segment. There we can see that the speed of the ship increases significantly. Why the captain or Sturman doesn't use the ship earlier and later, we don't know. And what's the main conclusion from our investigations? We estimate subjectively, not mathematically correctly, subjectively, we estimated the comparative impact of different uncertainty factors in the accuracy of ice routing. And we can see that the main problem is not forecast, is not numerical algorithms, is not ship transit model. We have more or less accurate ship transit model. The main problem is the monitoring of the key ice parameters such as thickness and concentration, recognizing of satellite images, because the difference in these data obtained from different providers is critical. And the conclusions of in text from and the most significant conclusions are selected by red. And for example, one of our big desire is that data on main parameters should be provided in physical dimensions, not in conventional coders, because conventional coders, it's very difficult to use in automatic procedures of ice routing. And so on. And thank you for attention. And I will be glad to answer the question if they will be. Thanks.
Thank you. Thank you, Alexander. I see there are some questions coming up on YouTube live chat. First, there is more like a comment from Kondratenko Alexander. He thank you for a very interesting presentation. And next, we have two questions from Vladimir Yakimov. His first question is, accounting these uncertainties, for example, differences in ice information, the final parameters of ship motions, primarily the speed, should be set in a certain range with certain deviations. Is it like this?
Yes, of course. the ship transit. Mathematically, ship transit model gives the result as a single value. Yes, of course. But we have the extension, the development of our approach, and we can get the result in our digital services also, not in the single value, but as an interval or as a histogram and something like probability distribution of the estimated value, like speed. Mm-hmm.
Yeah, thank you. And I hope this answered Vladimir's question. And his second question, Alexander, to you. According to the central limit theorem, it is likely that the total velocity will be distributed according to the normal law. This is more like a comment question.
I'm not sure that the probabilistic law of velocity distribution is really normal. Because, for example, I think that we have non-symmetric distribution. Because if we consider the rather difficult ice conditions, so ship can move slowly, but I think it cannot move faster than we estimate. Okay, something like that.
Yeah, thank you. Yes, so to answer Vladimir Rakimov, yes, the distribution is not normal, as I understood. Thank you. We still have some minutes. I think we can. I really enjoyed the presentation, and I think you have raised very important concerns about and points about the uncertain ice original information, not the forecast, but the original ice information. And in this view, I also have a little follow-up. Do you see some? Do those three products that you have considered from VNI, ARI, and OSISA or something like that? Do they all based on exactly same satellite images, or do they use different satellites? Do those satellite images taking at the same time, or this is the human factor? Why do they deviate? Or they don't, or it's not manual products?
I don't know it exactly. What the original sources, what the original images use different providers. But as I know, there are not so many different sources of ice satellite images, because not so many satellites observe the Earth in the polar latitudes. Yes, we have. I think that they use the free satellite images from MODIS, from Sentinel, and I know about the special program in China, the POAC, something like that, but I have never seen the free sources from this project. So I think that most of the ice providers use the same images for the same area and same time period, but the difference in diagnostic ice chart, I think this is mainly the subjective preferences of the ice experts, or non-accuracies of the routines of automatic recognition of the satellite images. I think so.
Would it help, like for your specific study and for the specific application practice of using these products? What would your message to these ice chart providers? Do they have to provide you an uncertainty estimate, or would you benefit from knowing the uncertainty and on which form this uncertainty have to be expressed? For example, this ice.
Ekaterina, we are a commercial company. And we are working together with commercial companies like Atom Float, for example, who is who is a responsible organization for navigation now in the field of the navigation of North Sea route. And our main message is that we need to have the only one in Russia, yes, for Russia, for Arctic navigation. We need to have the only one owner, only one responsible person concentrating and integrating all the routines needed for automatic optimization of path finding. We need to one owner for obtaining the satellite images, for recognition of satellite imaging to receive the diagnostic charts, to predict the future ice conditions for the forecast. The very big problem is the existence of alternative data sources. For example, the onboard observation. Every ship moving through the North Sea route can be the device of ice observer by means of not very expensive but very easy onboard equipment. So the concept ship as a device is very prospective, and we use the very valuable information for on-ground verification and validation of satellite data, because we use the onboard measurements of the ice characteristics, very accurate and so on. And all this activity must be concentrated in one hands.
Yeah,
it's our main messages. We use many times, long time to provide this very simple idea.
Yeah, I think it's a very good point to conclude our session. I hope your visions and wishes and messages will become the future for what you are doing for the safety of the Arctic navigation. And I would like to thank all presenters on this note, Ekaterina, Oleg, and Alex. Thank you very much. Thank you also for our technical assistant, Alexei, for being here with us. And for our listeners, I would remind that we will have a short break until 15:40 Moscow time, and then there will be another session, navigation problems in ice conditions, at 15:40. And on this note, I would like to thank you all for being here with us.
Yes, thank you for your convenience and patience.
Yes,
and very professional leading of our session. I was glad to see you again, Ekaterina.
Yeah, thank you.
Thank you.
Thank you, everyone.